The hidden limit every system eventually hits. No system fails all at once. It slows, it strains, it resists, and then it reaches a point it cannot cross. To understand why every system has a hidden limit, we need to abandon the idea of infinite growth. Systems grow by converting resources into structure, energy into motion, information into decisions. As long as inputs increase, output expands. Progress feels natural. The relationship between effort and result appears linear, predictable, and reliable. Early success validates the underlying model. More resources yield more output. More investment produces more return. This creates a powerful psychological momentum. Stakeholders come to expect continuous expansion. Strategies are built around perpetual growth. The very identity of the system becomes intertwined with its ability to scale without bound. This matters because modern systems are built around continuous expansion. More users, more speed, more efficiency. Growth is treated as proof of success. Limits are seen as technical problems waiting to be solved. Organizations measure themselves by growth rates, market share expansion, and the ability to handle ever-increasing loads. Stagnation is interpreted as failure, even when current performance is objectively strong. The cultural imperative to grow creates pressure that shapes every decision, from resource allocation to strategic planning to daily operations. But limits are not always external. They are often internal. They emerge from coordination costs, delays, and complexity. As a system grows, it must manage more interactions, more dependencies, more points of failure. Each layer adds friction. The relationships between components multiply faster than the components themselves. A system with 10 elements might have dozens of meaningful interactions. A system with 100 elements has thousands. This combinatorial explosion is not obvious at first because early growth occurs in a regime where interactions remain manageable, where adding new elements primarily adds capability rather than complexity. At first, this friction is manageable. Improvements offset it. Technology scales. Processes optimize. The system appears to stretch its limits effortlessly. Confidence grows. Investment follows. New capabilities are added without apparent penalty. Performance metrics continue trending upward. Teams celebrate milestone after milestone. The system seems to defy any notion of constraint, validating the belief that intelligent design and sufficient resources can overcome any obstacle. Success breeds confidence, and confidence breeds ambition. But beneath this success, a constraint forms. Communication slows. Decisions lag. Errors propagate farther. The system spends more energy maintaining itself than producing value. Growth continues, but efficiency quietly declines. What once required minimal coordination now demands extensive planning. Simple changes ripple through multiple subsystems, each requiring attention and adjustment. The overhead of managing complexity begins consuming resources that were previously dedicated to advancement. Meetings multiply. Approval chains lengthen. Documentation expands. The administrative burden of scale starts to rival productive capacity it was meant to support. Eventually, a threshold is reached where adding more no longer helps. It burdens. The same actions that once produced gains now produce drag. The system has not failed. New resources no longer translate into proportional improvements. Hiring more people slows down projects through coordination overhead. Adding more servers increases latency through network complexity. Expanding features makes the product harder to use rather than more capable. The returns from investment begin approaching zero, and in some cases turn negative. It is saturated, and saturation is the beginning of a very different phase. As saturation sets in, the system begins compensating instead of growing. Resources are redirected from expansion to maintenance. Complexity is managed with layers of control. Coordination replaces creativity. The focus shifts from building new capabilities to preserving existing ones. Innovation slows as teams spend their energy managing interactions rather than exploring possibilities. Problem-solving becomes reactive rather than proactive. The organization moves from discovery mode to stabilization mode, often without consciously recognizing transition. This shift is subtle. Output may still rise, but at increasing cost. Each gain requires disproportionate effort. Margins thin, resilience erodes. The system becomes busy rather than productive. Activity levels remain high or even increase, creating the appearance of health and momentum. But closer examination reveals that much of this activity is internal. Systems talking to other systems, processes maintaining other processes, people coordinating with other people. The ratio of value-producing work to maintenance work steadily declines. Mathematically, this reflects diminishing returns. Early growth benefits from simple connections. Later growth adds overhead. Every new component must interact with existing ones. The number of interactions rises faster than the number of parts. If a system doubles in size, its internal complexity can quadruple or worse. This nonlinear scaling means that intuitions developed during early growth phases become misleading guides during later phases. What worked at one scale actively harms at another. What makes this phase dangerous is denial. Because performance still appears strong, limits are ignored. Warnings are framed as inefficiencies to be optimized away. The system doubles down on scale, assuming size itself will solve the problem. Leaders point at absolute metrics, total users, total revenue, total capacity, that continue showing growth. They interpret slowdown as temporary friction rather than fundamental constraint. The narrative remains one of progress temporarily impeded rather than limits fundamentally encountered. But size amplifies constraints. Delays grow, feedback weakens, errors travel farther before correction. The system becomes slow to sense and fast to react, a combination that magnifies stress. Information must traverse more layers before reaching decision makers. By the time problems are recognized at the top, they have already propagated through much of the system. Responses, when they come, arrive with force but without precision, broad directives that cannot account for local nuance. Eventually, flexibility disappears. The system can no longer change direction easily. It must keep moving forward, even when forward is no longer viable. The momentum built during growth phases carries the system past a point where alternative paths were available. Commitments have been made. Infrastructures have been built. Expectations have been set. Changing course would mean abandoning investments, disappointing stakeholders, and admitting that previous strategies were misconceived. This is the hidden limit, not a wall, but a narrowing corridor. And once entered, turning around becomes harder with every step. The conflict emerges when the system reaches a point where optimization becomes self-defeating. Every improvement in one area creates stress in another. Gains cancel each other out. Progress feels forced instead of natural. Efforts to increase efficiency in one department create bottlenecks in another. Attempts to accelerate decision-making undermine coordination. Measures to reduce costs eliminate the buffers that absorb variation. The system enters a regime where local optimization produces global degradation. This is the emotional peak. Leaders sense that something is wrong, but metrics still demand growth. Slowing down feels like failure. Changing direction feels risky. The system is trapped by its own momentum. The psychological and political pressure to maintain expansion conflicts with the mathematical reality of saturation. Admitting limits feels like admitting defeat, yet continuing forward guarantees eventual crisis. This creates paralysis, an inability to change course combined with recognition that the current course is unsustainable. Mathematically, this is a regime shift. Constraints dominate behavior. The system's degrees of freedom collapse. Instead of exploring possibilities, it cycles through the same narrow responses. Adaptation is replaced by repetition. Where the system once responded flexibly to varied conditions, it now applies standard solutions regardless of context. Innovation gives way to iteration. Experimentation yields the procedure. The richness of response that characterized earlier phases contracts into a limited repertoire of predictable reactions. Attempts to push past the limit usually worsen the problem. Efficiency measures strip away slack. Redundancies are cut. Short-term output improves while long-term stability erodes. The system becomes impressive and fragile at the same time. Performance metrics may briefly surge as every ounce of capacity is extracted. But this extraction removes exactly the buffers and reserves that allow graceful degradation under stress. the system optimizes itself toward brittleness. At this stage, collapse does not require an external shock. Internal stress is enough. A delay becomes a crisis. A mistake becomes systemic. The limit reveals itself not as a barrier, but as a loss of options. The system has consumed its own adaptability in pursuit of efficiency. When disruption arrives, and it always does, there is no margin left to absorb it. What would have been a minor perturbation in a flexible system becomes an existential threat in a saturated one. The conflict is not growth versus decline. It is expansion versus coherence. And coherence has already been compromised. The resolution comes when systems stop treating limits as failures and start treating them as signals. Mathematics shows that every sustainable system operates within bounds. Ignoring those bounds does not remove them. It only delays their consequences. Limits are information about the relationship between structure and capacity, between ambition and capability. They mark the boundaries where current architecture can no longer sustain current demands. Respecting limits is not surrender. It is intelligence. When limits are respected, design changes. Growth is paced instead of forced. Complexity is reduced instead of layered over. Capacity is matched to coordination. The system regains room to breathe. Resources previously consumed by internal management become available for productive work. Decision-making speeds up as coordination requirements decrease. Errors are caught sooner because feedback loops are shorter. The system rediscovers agility that had been lost to scale. This shift feels uncomfortable because it contradicts modern instinct. Slowing down feels like loss, but mathematically it is recovery. By operating below saturation, systems regain flexibility. Small changes matter again. Feedback becomes meaningful. The system moves from a regime where behavior is dominated by constraints to one where choice and adaptation remain possible. Performance may temporarily plateau in absolute terms, but efficiency and resilience improve dramatically. The hidden limit was never an enemy. It was a warning, a message that structure had outgrown its ability to adapt. Systems that survive do not push endlessly forward. They learn where to stop, and stopping at the right moment is what allows them to continue at all. Subscribe to join the journey. The